Good day, everyone. We discussed on our last video about process, threads, scheduling, quantum, context switches as a whole. In this video, we will talk about scheduling in terms of SQL Server. Let's get started. If we remember what we discussed on our last video, and how thread gets scheduled on a CPU, how long it stays and when it yields, the main question that might come to our mind is what will happen to the executing thread if some resource it needs is not available? That thread will be on the CPU and will just wait on the CPU without executing or performing anything, and then yields after 4 milliseconds or whatever is the quantum, as it is not able to run, as the resource it is looking for is taken by something else, or maybe a different process or a different thread. To put things in perspective, let's consider we have one update statement on an object called table1 that is using one thread, and then close to 10 select on table 1, object table 1, using 10 threads executing with a default isolation model of read committer. Yeah. So we know each select uses one thread. If the SQL server utilizes the preemptive scheduling of scheduling all its threads, then that means like it will be presenting all the 11 threads, that is one for update and then 10 for the select, will all be there on the CPU ready list in case if SQL Server is going to utilize completely, that is, it is completely based on the preemptive scheduling of the Windows. Now let's consider that the update thread that we are seeing here at the end of the ready queue is running on the CPU. Let's consider it as running on the CPU for 4 milliseconds, okay? And what will happen is like it will basically run for 4 milliseconds or whatever the quantum is. And once it quantum is complete, what it will do is like basically this update statement will be added to the top of the ready queue. And then what happens is like the next select statement or the next thread that is going to execute the select statement will be moving to the CPU processor. So in this case, what will happen is like now that this update statement on object one is holding an update lock, what will happen is like this select statement will basically has to wait because it will not be able to take a shared lock as a conflicting lock is already taken by the update statement. In this case, what will happen is like if this is scheduled this way, like when SQL Server presents all its thread, which is not the case as far as the real SQL Server scheduling is concerned, but just in case if we think like that, what will happen is like this select statement will be there on the CPU for 4 milliseconds. And then once its quantum is done, then it will go on to the top of the ready queue and the next select statement comes in. And likewise, all other select statement will be just waiting on the CPU without doing any work, and then it will be added back to the ready queue. So as we know, like since it is all waiting due to this conflicting lock, there is no way we will be able to solve it if we present all the threads from SQL Server to CPU, because what will happen is like for this particular single update statement to complete, all the select statements will have to wait till then. So in that case, there is a problem if we send all the 21 threads directly to the CPU. So in this particular case, 10 threads executing the select statement will basically waste 10 into 4 milliseconds quantum, which is close to 40 milliseconds. And this wastage will go on till the update statement finishes its work. This will be the case if SQL Server uses preemptive scheduling process. Yeah. But just think of a way what will happen if we don't introduce all the 11 threads of, let's say, like at least the 10 threads of the select statement to the Windows and just let the update statement thread to run on the CPU. In that case, we will not see any kind of CPU wastage by the select statement, and this update statement can complete faster. This is the reason SQL Server will not introduce all its available threads, but only one thread of SQL Server per CPU that is available at the top of the SQL Server ready list. This kind of scheduling by SQL Server is called non-preemptive scheduling. SQL Server developers realize that introducing all its threads at a time to Windows will result in costly context switches frequently and end up wasting the CPU resources as advised previously. So they decided to utilize non-preemptive scheduling instead of solely dependent on Windows preemptive scheduling. So SQL Server will handle all its thread efficiently possible internally, and then SQL Server design introduces only limited threads at any point in time to Windows scheduler. How did they do this? They basically utilized a C++ code that calls function wait or wait for infinite, which Windows will not schedule and basically ignore those threads from scheduling. Let's load a dump. Let's use the same dump that we have created before, like we tried creating a user initiated dump. So let's use the same thing. And what we will see is like, let's look at the stack and see what are the threads basically waiting on. Yeah. So I've already loaded the dump. In case if you have any questions how to configure Windows debugger, then you will have to watch my first video. Okay, so let me look at how many threads we have on as far as this user initiated dump is concerned. I'm able to see close to 106. So if we look at any threads here randomly, what will happen is like we will be able to see that these threads are basically waiting on the wait function, which tells the Windows not to schedule on the scheduler. Yeah, so let's try looking at any random thread. Let's say 78 this time. And if I do a KC, what I can see is like it is basically using the wait function, anti-signal and wait for single object. Okay, let's try one more. This time, what we can select, okay, let's do 60. And then let me try a KC here and same. This is also waiting on anti-wait for single object, yeah. And this would be the last one. Let's try the last thread, which is 106. And what is this doing? It is again doing the same thing, anti-wait for single object. So this way, what we are basically doing is like, we are calling, let's consider like what are threads that is not considered to be scheduled as far as SQL Server is concerned. So these threads basically calls the wait function, which in turn makes the Windows not scheduling these threads. So that is how this is achieved by the SQL developers. So as discussed before, we cannot hide threads of any application from Windows. What SQL Server does is it will make sure that the threads that are not ready for the from SQL Server perspective will all wait using wait function, which in turn will make Windows not to schedule these threads. If we get more deeper into this, SQL Server will maintain a gateway, which in turn has got 5 queues, and these 5 queues are runnable queue, waiter queue, IO queue, timer queue, and then the last one is worker queue. So if we talk about runnable queue, this queue contains threads that are ready to execute, but its turn on the CPU is not yet arrived. So these threads are ready and are not waiting on anything, has all the resources required for the execution, but it is just waiting for its turn on the CPU. Next one comes as the waiter queue. So this queue contains threads that are blocked, that is, they are waiting on a resource due to a conflicting lock. Any thread that are waiting on something will be placed in this queue. So for example, when you run a sp underscore who or a dmv sysdm exec request, you will be seeing some threads on suspended status. So those threads basically will be present in the waiter queue. The next one comes in the list is IO queue. And this queue contains threads that are waiting, that are basically waiting for IO completion. Next one is timer queue. This queue contains threads that are on a scheduler, for example, a thread that will wake up for every 5 or 10 seconds and has to do something. For example, you execute a wait for delay. These threads will all be placed here. Next one, the final one would be the worker queue. So this queue contains requests that are waiting for a free worker thread. SQL Server is designed in a way to present only one thread at any point of time, that is at the bottom of the runnable queue to Windows, that is the CPU. All other threads in the runnable queue will be calling wait for infinite, and that way Windows will not be scheduling those threads. Now, when this one thread goes to CPU, it will compete among other threads from other application and execute for say one quantum or maybe two quantum or maybe n quantum before it reaches its yield point. This yield point for a thread will be defined on the SQL Server code, and depending on that, after certain quantum, this particular thread belonging to SQL Server will add it to the top of the SQL Server runnable queue if it has more work to do or is not blocked by anything else. Let's consider that SQL Server thread executing is looking for something that is not available at that time or is blocked by something else. Then it yields and moves to the SQL Server waiter list this time. Same way, if the SQL Server thread executing on the CPU requires an IO to be completed, then in this case, it yields and adds it to the SQL Server IO list, and the next thread at the bottom of the SQL Server runnable queue will now get to the Windows CPU and compete among other threads from other application as discussed previously. Whenever a SQL Server thread yields, before getting into one of the SQL Server queue, it needs to perform some sort of a janitor task. So janitor task refers to the task that the yielded thread should perform. Basically, it moves the last thread in the runnable queue to the Windows CPU, then check other queues such as waiter, IO, timer, and the worker queue to see if any of the threads that are ready, and if yes, then pushes it to the runnable queue. For example, it checks the IO queue. In case the IO that the thread is waiting for is complete, then it pushes that particular thread to the runnable queue and then adds itself to the required SQL Server. One thing to understand is, even though we present one SQL Server related thread per Windows CPU, if there are many non-SQL Server threads on Windows CPU ready list, then there is high possibility we might not be able to perform well. That is, the SQL thread will not be performing that great as we will be spending much time at the ready list rather than executing on the CPU. So this could be like compared with the signal weight that we are seeing. So we will be ready to execute on the CPU, but if you are not getting the chance to execute on the CPU because of other threads, then this could be a problem. This is the main reason we follow a best practice that we shouldn't install any unwanted application on a database server. That's it for this video. We will speak more about scheduling in terms of SQL Server on my next video too. Thanks for watching. Have a great day. Jai Hind.